Hey guys, it's me, Dr. Polly. I know you're excited to hear my voice again. Um, Today we're going to go ahead and we're going to do the crankshaft. Now, I'm going to go about the crankshaft a little bit different than they do in the book, so kind of follow along. And here's my reasoning. I'm going to use my origin. I'm going to place my origin right here where that my mouse is, and the reason is that I can split this section in two vertically. So what I'm gonna do is I'm gonna build this central shaft right here, and then I'm gonna put this collar and this bell, for lack of a better word, for the crankshaft. And what I'm gonna do is, once I get those two built, I'm gonna flip them over to this side, okay, mirror them. And then I'm gonna come through here on my origin horizontally, and I'm going to build out this section here, and I'm going to revolve it around, and that way I don't have anything where I have to like cut out the middle. Alright, so that's the plan. So we're going to go ahead and create a extruded boss, and I'm going to do it on the right plane. This is my origin, so this top part is actually going to be above it, so I'll go ahead and line up a circle, put a dimension on it. The dimension for that circle is going to be 0.625, and the position of that circle is going to be 1.125 above the origin. And I'm going to hit escape, and I'm going to go ahead and make sure that these 2 points are locked horizontally, so that locks it in place. Alright, so there's that. I'm going to finish it. Now the trick is I'm going to do a mid-plane extrusion, and that distance is 0.850, and we're finished with that. Now I'm going to do another extrude boss on this side. I'm going to use another circle. The diameter of that circle is going to be 1.135, so 1.135. Enter. That's good. Finish. And I'm going to check my extrusion here, and my extrusion is going to be blind, and it's only going to be 0.125, and that's that collar. And now to do, for lack of a better term, the bell part of it, I'm going to do an extrusion on this surface. Now, if you notice let me pull this back over here, leaders point to circles. They point to the origin or the center point of the circle. So if you follow like 625 in, not only does it point to the actual circle, but if you were to follow that arrow in, it would point to the center. So we're going to do this bell shape here. All right, so I know I need a 7.5 radius for this outside circle, but this circle here, or this radius, that 2 radius, if you follow that leader, you'll notice that this is the center for that, okay, not here. I've seen some of you guys mess up, and you try to do the radius, centered both of them on here, and that's not going to work out for you. So at this point, the way I lined it up is actually the origin, okay? So let's move this back over here, and let's get those 2 circles drawn. My first circle is here. My second circle is going to be from there. Now let's go ahead and put a dimension on this. Since the radius is 2, diameter is 4. On this one, it's a 0.750 radius, 750 times 2 to get the diameter, and there's that. Now, similar to the crankshaft, not the crankshaft, the forgot what it was, connecting rod. This bell is based off of an angle of 15 degrees. So just like that, I'm going to go ahead and follow the same system that I did for the connecting rod, and I'm going to snap to this circle and then to the lower circle. Now notice that I should have tangent constraints. If I don't, then I need to select these two things and make them tangent. Coincidence down here and here. Now I'm going to go ahead and dimension from this line to this line is going to be 15 degrees. Okay. Give myself a center line straight down, and then I will go 7.5 degrees, or 15 divided by 2 for the mathematically challenged. And there we go. Now, I need to trim, and I'll get rid of this part, and I don't need the lower part here. So there is that bell housing thing. All right, so we're good with it. It's fully constrained. Everything's good. So I'm going to finish that, finish my sketch. And the distance that I need to extrude this is going to be 0.3 thick. Now, I've got this part of it completed. Now, the next thing I need to do is go ahead and get that chamfer here. So let's go ahead and knock that chamfer out. That chamfer says that it is a, well, it doesn't tell you all at once, but it's got 0.2. Here, I'll point it out. All right. It's 0.2 for the distance and 65 degrees. And what's going to happen is we're going to end up having to flip this, okay? And I'll show you that here in just a second. So I'm going to go here under fillet. I'm going to say chamfer. And the distance is 0.2 and the degrees are 65. Now, I'm going to take off this tangent propagation, and I'm going to pick this inside corner right here. Now, if you notice, it doesn't look right, okay? That's because it's applied the 60 degrees this way. So I'm going to say flip direction, okay? And now my 60 degrees is applied here, all right? And there it is. And so I will go ahead and say okay. And there is that nice chamfer. So we've got that. And remember, we did a mid-plane extrusion here, correct? So I'm going to go ahead and say, all right, well, it's time to mirror. So I'm going to find mirror. My mirror plane is selected, and I'm going to use my right plane. And because my right plane is right in the middle, right there, okay? Features to mirror. Now, I could go through here and click, 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 and all this other stuff, but the easiest way is to go ahead and pick the features out of your tree. I'm going to hold control so I can select multiples, and I'm going to pick just the ones I need, which are these three, okay? And there they are there, so I'm going to say okay. And we've got it now up to that point. So that's that part of it. The next part we're going to work with is, let's go ahead and put that little fillet on there. I should have done that beforehand, but oh well. I'll knock them both out. There's a 0.25 fillet right on this edge here and here. You can't leave that out. So let's say fillet 0.250, and it's going to be, I'll move it around so you can see, it's going to be on this edge, and it's going to be on that edge, like that. And hit enter. And so let's go ahead and knock that out of the way so I don't forget it later. Okay. Now the next part, let's see, control 1, is I'm going to do a revolve boss, and I'm going to pick the front plane. Okay. That's what I'm going to do it on. Now, first thing I'm going to do is take a center line. I'm going to line up with this, and I'm going to touch, I'm going to do coincident with this edge straight through the origin, and coincident with this edge, like that. And it should be locked in place. Now that's my center line of rotation, my axis of rotation that I'm going to use. So now I'm going to use a standard line tool. I'm going to start from that, and I'm going to build the shape of half of what I'm going to revolve. And it doesn't have to be perfect. I'll snap the dimensions in, and then I'm going to come straight back in like this. Okay, so there's that half of it. And see, I'm doing it this way so I don't have to cut the middle out. And then I'm going to go here, and I'm going to mimic this piece out here like so. Now, before I really get started, I know that this piece, this piece, this piece, and this piece share the same diameter. And so I'm going to do myself a favor, and I'm going to go ahead and select all 4 of those lines, and I'm going to make them collinear so they're along the same line. So if I dimension one, they all change. Okay, and I'm going to do the same thing with these 2 lines here, this one and this one. I'll make those collinear because I know that's the same size groove. Okay, it's just something to help me out here later. So let's go ahead and get some dimensions on this. I'm going to get my horizontal dimensions first. So I'm going to dimension from here to here, and that distance is going to be 6.570. All right, 570 thousandths. From here to here is 3.230. And if it moved it in here like a little bit there, I'm not too worried about. I'll just hold control and grab these lines and move them that way, just to kind of clean them up. The distance from this point to this point is 2.2. Okay. The distance from here to here is 1. So there's that. Over here, again, that got shifted around, so click, 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 pull. There we go. Let's kind of get that sorted out. Now, if you notice that, let me see if I got all those dimensions. I don't. Now I need to dimension from here to here, and that's 0.480. All right. And this distance here to here, then that's the detail of that groove. So from here to here is 0.046, so 0.046. All right. Same thing here. 0.046. All right. Now let's put our depths in. If you notice that almost everything is constrained now as far as the horizontal dimensions go. So now let's go ahead and dimension, and let's get this height here. Again, if we want to be lazy, I can sit there and say dimension from here. Now I have to hit a center line. So let me get back here. Here we go. Here to here. If I hit a center line, then it'll let me do a diametric, and that is 0.750. From here, and see, it automatically starts feeding it to me that way. It's a 1-inch diameter. Now the cool part is, since I had everything constrained, all that stuff will move. And now for this one to here is going to be 0.940, 940, and that drops that in. So everything should be fully constrained. You see how, because I made these collinear, it kind of dimensioned this side too for me. All right, so we're good there. Finish that. It automatically picks my axis for me because it was fairly intuitive, and say OK. And so there's that part of the crankshaft. Now let's go ahead and fill it out with everything else that's necessary. I've got a radius of 0.125, so I'm going to say fillet 0.125, enter, and it goes on this side, and this side is the only place I think that fillet goes. I'm going to say yes, enter. Up here on the top of this shaft should be some kind of chamfer. Nope, it's a fillet of 0.025. So I'm going to go fillet again, 0.025, enter, and it goes, looks like in two places. Should go here and here, and here and here. Okay, so there's those. What else we're looking at here? I want to say that's I've got some chamfers. I keep looking for it, but it's hard to see. I want to say that's a fillet. I'm looking for it because I see the markings of it. All right, I think it's also a point. So I'll show you what I'm looking at here. If you notice, let's see, I have to do this manually on this. You can see that there's either a fillet or a chamfer on this end. Oh, here we go. There they are. So it's 025 by 45 degrees here and here. What you don't see is this right here. You see that hidden line? That denotes a fillet, if I'm not mistaken. So there's going to be a fillet here. And I'm assuming, which will get you in a lot of trouble sometimes, that's going to be an 025 fillet. So we're probably going to have to go with that. All right, so we got a 025 by 45 chamfer here, and we're going to do an 025 fillet on this right here. So, all right, let's go ahead and knock out the fillets since we're already in fillets. So another fillet, actually, you know what? I'm not going to make another another feature just for that. So I'm going to click this, I'm going to edit the feature, and I'm going to add that fillet to there, okay? And say okay, and it adds it. And now we're going to do a chamfer, and it is a 0.025 by 45 degrees, and it's on this end and this end, like that. All right, so that should be it for as far as that goes. Now the next thing we need to do is we need to work on this slot here, okay? And if you pull up your drawing and you look at that slot, okay, they give you all the information you need. The slot goes back 0.875. The depth of that slot is denoted by the radius here of 0.125. So it's 0.125 deep, and it just comes off into a radius here. All right. So 875, 125. So what I'm going to do is I'm going to say, okay, I'm going to do an extruded cut this time. And that cut is going to be based off of my front plane, my top plane, my front plane. All right. And if you look, well, it didn't help much there. Control 1. We'll take a rectangle tool, and I'm just going to kind of draw in like this. Okay. Now we can look at it, and you can see it's right down the middle of this. Okay. So Control 1 to get this sorted back out. I'm going to dimension from this line to the bottom edge here, 0.125. And from this point to here, the front, I'm going to dimension it as 0.875. Okay, so that pulls it that way. Honestly, this part here doesn't really matter that much, neither does this. If you want it to be nice and clean drawing, I could easily take this line and just grab a point like that and make them coincident, so that'll pull that down, and then grab this this line, hold and this point here, and make them coincident, so it kind of tucks it in, just to make it nice. Now I need to put my 125 radius here, so fillet 0.125 radius, this corner. Specified radius would delete one of the elements. Oh, and what element would that be? Let's see what I'm running into here. Probably just because the way I put it together. Here to here, won't do it. Alright, so what I need to do is get rid of something. Probably these coincidences. So let's delete this, let's delete that, and let's see what happens now. Fillet. Well, that's not going to be good. Let's see, let's get rid of another. Let's get rid of this dimension here then. Let's see if that frees it up. I guess not. That's strange. I've got eliminate one of the elements. Yeah, okay. Let me back up here. Put all that stuff back. I'm just going to cheat. We'll make a circle. Snap it to here. And then I'm going to dimension from here to here. 0.125, which is the radius. See how that works there. Trim, knock off the top here. Knock off that. Knock off that, and knock that out. And I don't know why it threw a fit on me. I'm sure if I dug into it, I could figure it out. But 875 works for me. And there we go. It's probably just the way I had some of the geometric constraints attached to each other. But, instead of using a fillet, I just made a fillet, which is the exact same thing. All right, so we're good there. There's my sketch. Now I'm going to go ahead and finish. And it wants to extrude, but it's going to say it's going to try to go one way, but I need to do mid-plane because it's in the middle. And the thickness of that is 0.188 thickness. Okay. And I'm going to say okay. And if we look at it, it's nice and clean. Good cut. Okay. And there is that keyway. I'm trying to see if there's anything else I've missed here. I really don't see anything that I might have missed. So we should be good. Yeah, we should be good. All right, so that is the crankshaft. So let's see, Control 1. And now, let's save it. Let's see, what's the material? Alloy steel. So material, right click. I should have alloy steel up here, maybe. That's cast alloy steel. That's not the same thing. So let's go edit material, steel, alloy steel, apply. So we're good there. Let's save it. So file, save as, and I'm going to call it crankshaft, and save it. And there it is.